Okay, now we're back for number 2. Release the FRQ from the 2023 AP Calculus AB exam. Stephen swims back and forth along a straight path in a 50-meter long pool for 90 seconds. Stephen's velocity is modeled by 2.38 times e to the negative 0.02 t times sine pi over 56 times t. That's his velocity, where t measured in seconds and v of t measured in meters per second. Find all times t in the interval 0t to 90 at which Stephen changes direction. Give a reason for your answer. Since this is velocity, positive velocity would go in one direction, negative velocity would go in the other direction. So we need to find all the times, critical points, where the velocity could change directions. So from 0 to 90, we're going to set our calculator up. We're going to get this function graphed. Y equals, clear the old function out. We're going to do 2.38 times e raised to the negative 0.02x times sine pi divided by 56, and then times x. Calculator follows the order of operation, so we're all good with that function entered like that. Now we're going to go ahead and graph this function on 0 to 90. I'm going to set my window up from 0 to 90. I'm going to go ahead and set my y min velocity in meters per second. Swimming, probably not going to be super fast. I'm going to try -5 to 5 and see if we can see what we need to see there. Okay, I'm going to adjust the window a little bit there and make this -2 to 2. Well, -3 to 3. We'll try -3 to 3. Get a little better look at it. So the only places that this could change direction is when the velocity goes from positive to negative or negative to positive. And it looks like that happens one time, so I'm going to find second trace 0, the left bound and the right bound. Okay, so the velocity function, v of t, put this as 90, and looks like this is going like this. And this t value is at 56, which makes perfect sense. Seconds, and this is in meters per second. Okay, and so that means that the velocity t is greater than 0 from 0 to 56, and v of t is less than 0 from 56 to 90, and v of t equals 0 at t equals 56. And so we're going to say find all the times t in the interval 0 to 90 change direction. So Stephen changes direction. At t equals 56 seconds. Give a reason for your answer. And we know this because v of t changes from positive to negative at t equals 56 seconds. That's part A. Part B, find Stephen's acceleration at time t equals 60 seconds. So acceleration is v prime of t, and so a of 60, a of 60 equals v prime of 60. And since we can do that in the calculator, we will say second quit, math, numeric derivative. We have x in our calculator. We have, oops, it's not going to do. Y bars, y1 is the function we graphed there. We want to check this at t equals 60 or x equals 60. So this is equal to negative 0.036, and the acceleration is going to be in meters per second squared. Shows how indicate units of measure. Is Stephen speeding up or slowing down at time t equals 60 seconds? Since v of t, the velocity, is negative, at t equals 60 seconds, and a of t is negative at t equals 60 seconds. Stephen is speeding up. At t equals 60 seconds. That is increasing speed in the negative direction. See, find the distance between Stephen's position at t equals 20 and his position at t equals 80. Okay. So his position, we'll call it S of t, is equal to the integral of v of t from 0 to some a. So S of a, we'll just call it S of a. Oh, we're going to use a. Let's use S of x to some x dt. So if we want to know the position S of 20, we're going to integrate from 0 to 20 v of t dt. If we want to know the position at t equals 80, S of 80 would equal the integral from 0 to 80 of v of t dt. And the distance between Stephen's position is going to equal S of 80 minus S of 20, or the integral from 0 to 80 v of t dt minus the 0 to 20 of v of t dt, which equals the integral from 20 to 80 of v of t dt. So we're going to do that. Make sure I've got my right v in here. This is the correct function in the calculator. And so I'm going to get out of this, and I'm going to math again. Oops. Go down to the integral, and we're going to go 20 to 80, y1, with respect to x. And so that's going to be the distance in meters, 23.384 meters. Is the distance. Between Stephen's position at t equals 20 and t equals 80. And let's do part D. Find the total distance Stephen swims over the time interval from 0 to 90. So total distance is going to equal the integral from 0 to 90 of the absolute value of v of t dt. So here we go to the calculator again. This time we're going to go back to the integral. We're going to go from 0 to 90. This time we'll do absolute value. And we're going to put in y1 again with respect to x again. We'll wait on the calculator to finish its calculations. So he swims 62.164 meters from t equals 0 to t equals 90. And that should be the solutions to number 2. So we'll stop this video and move on to number 3.